So a pebble of mass m equals 0.5 kilograms is dropped without initial speed from the position O at the top of a building of height h equal 45 meters relative to the ground level, which has been taken as a reference level for the gravitational potential energy. The pebble describes a rectilinear trajectory and hits the ground level at the position A. Ignore the effect of the air resistance. Take g equal 10 meters per second squared. Now the pebble is at O. Calculate the value of the gravitational potential energy of the system. The rule for gravitational potential energy is mgh. And please don't forget to write the index O here to show that you are calculating the gravitational potential energy at this position. So 0.5 times 10 times 45, all the values here are given in SI units, so it's 225 joules. Now the kinetic energy of the pebble at position O. We are given that the pebble was dropped without initial speed from the position O. So this means that V at O is 0 meters per second. So it's half mVO squared, which is equal to 0 joules. The mechanical energy of the system at O is kinetic energy at O plus GPE at O, which is 0 joules plus 225 joules. It is equal to 225 joules. Specify the energy conversion by the pebble during the downward fall. What happens is that as the object falls down, its height decreases, and thus its gravitational potential energy decreases because GPE is directly proportional to the height. So when the height decreases, the kinetic energy increases because the mechanical energy is conserved in this case. So in order to keep this sum equal constant, the same, so as GPE decreases, kinetic energy increases. That's why in this case, the energy is being converted from the stored energy GPE to kinetic energy. Now the mechanical energy of the system is conserved. Why? Because we are given that air resistance is neglected. So nothing is opposing the motion of the pebble and nothing is causing it to lose mechanical energy. But we have only conversion from gravitational to kinetic. Now determine at position A the mechanical energy of the system. You would think about it in two ways, either by saying mechanical energy at A is GPE at A plus kinetic energy at A. However, you don't have enough information. You don't have the speed at A to calculate the kinetic energy of A. That's why you have to find another way to solve this problem, which is simply by making use of the previous results. You know that by now that the mechanical energy is conserved. So you can say that mechanical energy at A is equal to mechanical energy at O, which is equal to 225 joules, due to the principle of conservation of mechanical energy. Now having the mechanical energy, the kinetic energy is mechanical energy minus GPE at A, and GPE at A is 0 because the height is 0 meters. So you have to mention this. You have to mention GPE equals 0 joules because the height is 0. Point A is on the reference. And now the speed of the pebble. Having the kinetic energy equal half mv squared, we can work it out to find the expression of V as a function of kinetic energy. So kinetic energy is half mVA squared, which means mVA squared over 2. We are looking for V, so we multiply both sides of the equation by the reciprocal of the coefficient of VA squared, so times 2m times 2 over m. So it's 2 kinetic energy over m equal VA squared, but we are looking for V, so we have to do square root here. You can directly memorize this formula, or you can just do the same work we did here. So now the speed at A is radical to kinetic energy at A over m. All the values are in the SI unit. 2 times 225 over 0.5 is radical 900, which is equal to 30 meters per second. Now in the reality, air resistance exists and the pebble loses 20% of its mechanical energy as it falls from O to A. So in what form of energy does the energy lost appear? It appears in the form of heat or thermal energy. Calculate the value of the mechanical energy of the system as it reaches A. So they said that it loses 20% of its original energy. So mechanical energy at A is mechanical energy at O minus 20%. 20% is expressed mathematically 20 over 100. Of is times, so 20% of the mechanical energy at O. Do the substitutions, you get 180 joules. Now calculate or deduce the variation in the mechanical energy as the pebble falls from O to A. The rule of the variation in the mechanical energy is mechanical energy final minus initial. The final position here is A and the initial position is O. So 180 minus 225 joules is minus 45 joules.